go. All right, it should be being recorded. Cool. So today, step out of that. What we're going to dive into is I want to hopefully get to some component state stuff. But before we get there, we need to talk a good deal about classes and just objects in general. And I'm not sure if we'll end up making it to component state. We may do a quick overview of some of it at the end of class, because objects are a huge concept. Dealing with objects, dealing with classes, right? Like that's, you know, weeks worth of time in a traditional programming course. And we're going to sort of just try and touch on a little bit, but I suspect we'll end up getting into some of the details and having to go through a lot of different examples to help stuff click as well. But other than that, let's get going. So far we've only written functional components, right? And it's been nice in a sense, like we've got this nice little function. It's easy to create a component, but they're all stateless. So what that's meant is when we wanted to do something like, this is a different version of this clock or like timer example that we had before. And I've written it just a little bit differently. So it's a clock and showing some stuff, but there's no state and there's no way internally in this like component for me to do some sort of re-rendering or cause my UI to update, cause it to change something. So in this case, when I wanted to handle that, I had to pull that out here, right? The logic is in this set interval, which just calls render again, which is just updating something. And before, like I had, like we could go look at it. We had like the tick example, which was just showing a timer ticking up, and that tick was sort of value was kept out here in the same way. And whenever we called into our stuff, right? So they're really nice and easy to reason about when you're looking at these sort of functional components. But the thing missing is this sort of state so that you can change what's going on in your React app easily. So like I said, the only example we had of state living outside the component was the timer one. This is the classic timer, right? Where this is the only state that we have in this whole application is time equals 0, but it's ticking up over time and changing. And we're just re-rendering our components every second, roughly. So then the trick here is to build stateful components in React. We can't use functional components. They don't support keeping state around. So if we want to actually have the React components manage any of our state or deal with it directly, as opposed to handling it outside of it in the rest of our JavaScript app, like we just did in that timer, then we have to use class components. So that's what we're going to be introducing, is the concept of working with class components. And class components have mutable state where functional components can't. They just isn't something that exists on them. And does everyone know what like mutable state means? That makes sense? Changeable state, yeah. Because you can't, like, once you've rendered your function, you can't change it. It's immutable, it's done. Whereas mutable state means something you can change over time and it'll still be the same object or something. So the way we do that is classes. So let's just dive into JavaScript classes. And that's what we'll talk about. Now, really, I'm going to pause for a second before we get too deep into it. This is for anybody who's familiar with other programming languages that use objects or classes. So a small background on this is JavaScript is fundamentally different than other object-oriented programming languages. Unlike every other language, classes are not the fundamental way to create things in JavaScript. That's not the only way to create objects, and everything in the language doesn't have to derive from a class or be based around a class. So in most object-oriented languages, that's the case. In JavaScript, everything is actually, every object is just an object at its core. And we've already seen that a lot. We've worked with that exact thing when, didn't I shut that down? When we, created just object literals without any class whatsoever on them, right? Yeah, the lights are on the front, huh? They're probably the ones over there. So we've done that, right? We've created these object literals. With, I don't know what to say, like, we'll just go with that one. But we've created object literals like this. We didn't, the key thing here is, anyone familiar with another programming language or something like that? We didn't have to use a class. We didn't have to build a class to create this object. That is an object just like any other object. So in JavaScript, unlike these other programming languages, classes are just syntactic sugar for creating objects. They're just another way to create objects so that people who are comfortable with working with classes have them there available to them to create them that way. There are plenty of other ways to create objects, as we did here, that are just as valid. The only difference is React has basically two ways to create React components. That's the functional components and their class-based ones. And so that's why, even though we could, with JavaScript itself, avoid ever using classes, because it's just a little bit of sugar to make stuff nicer for other things, we're going to learn it because of React. Does syntactic sugar make sense? Anybody know what that term means? No? It's just, it's a term for, it's common in programming. It just means making something easier to do. So like if we said, equals 42, right? And we have let name equals Jared, I don't know. You guys have, we've all written out strings where it's something like this. We're like, okay, we want to write something out. Let's say plus name plus like period. Right, we've written something like that out. And then, what we've been writing in class for a lot of that type of stuff now has been like this backtick version, right? This is an example of syntactic sugar, because these two things do the same thing. And this version right here that we wrote, this ultimately, for the most part, gets converted to this exact same bit of code here when JavaScript runs. But, when you write out a lot of these, it's a lot nicer to not have to put that weird spacing in. Remember to get it right before your quotes, after your quotes, get your period in afterwards, etc. Right? So all we mean by syntactic sugar is it's something that's in there to make the language easier to work with, but it's not the only way to do something. It's just a nice way to accomplish a task, or it makes something that's a little cumbersome easier to do. So that's one of the key things to know about classes in JavaScript, especially for somebody coming from another language, is it's just syntactic sugar around creating objects. And that leads to not that much difference in terms of how you work with them, but there are some core underlying differences about how they actually work. So let's take a look at the syntax. You guys have already seen this before. This is just sort of the definition, raw definition. To create a class, you use the class keyword followed by whatever the name is that you want for your class, and then this optional extends keyword. Then inside of the curly braces, you have your class body. So everything inside there is your class body. Does that make sense? All right, let's look at a very simple example. So this is about as basic as you can get here. So we have a class. It's just a person class. And then all it has on it is this method greeting. So we can create an instance of it. Let me equal new person. We can give this instance a property, like name equals Jared, and then we can call the method on it. So we can put this in to Node and just see that it works just fine. Are there any questions on that? Come over here, we can get some better syntax highlighting. Yeah.
Down towards the bottom where it's me.name.
Mm-hmm.
I don't know how to word my question. That's putting, assigning a key and a value to that instance of person. Is that right?
Yeah.
Roughly.
Yep.
But that key and value doesn't exist. You didn't program that into the class itself. You just added it in.
Yes.
Correct?
Yeah. Okay. Actually, let's. I'll go backwards in just a minute. Let's have to know pop quiz about objects. So quick pop quiz on this. What is a JavaScript object composed of? All right, that's a step. That's going even a step farther. What do you know? What a key value pair is called on it? What? It's called a property. So it's composed of properties. And then, well, we've already answered this. What's an object property composed of? A key and a value, right? Now let's ask one specific one that has a special name. What is another name for a property that has a function as its value? A method. Yep. Great. Yeah, so going back here, I just added this name property to this instance of the object. And that, in general, can be done. It's possible, I believe. I don't know if I've ever done it. You might be able to lock. I think you can lock down an object to say, like, you can't add anything else to it. It's not that common that you do that, but I think it could be done. Yes?
So after the line for the return to low,
Yes.
is that standard?
Yes. We'll talk more about that in a minute. And I hope that'll clear it up a little more, but I was hoping somebody would ask about that. So there's a couple key things in here that, you know, are a little different than other stuff you've worked with probably, other than objects. So you use the new keyword to create an instance of an object from a class. So if we go back here, you can see new person. So this new keyword followed by the class name invoked as a function, right? So it's got the parentheses around it as sort of a function invocation. Yes?
Is that new? You were doing the same thing as, for example, I've seen like new date or some of those things. That it's doing the same thing.
It is, yes. Yep, whenever you use new in JavaScript, it's doing that exact same thing. And so I'm going to show you, this is going to show you that you don't have to have classes to do this stuff, but I'm not going to ask you guys to learn this right now. Let's implement this whole thing a different way. So I'm going to re-implement this person, but it's not going to be using a class, and we'll still be able to create instances of it using new. So this time I'm going to create a function and call it person. It's pretty much the same as what we had before. I'm going to do stuff a little differently here this time, so bear with me on the syntax differences, but we don't have to, this can be newed up as well. So a function is really, this again, I don't expect people to understand all of this, but this is actually what's happening with the class is something like this. So we could create an instance of this directly by doing just let me equals new person. And then I can even do me.name equals Jared. And I'm an object, like this person object with name. So I use that same syntax. Now, the one thing that's missing here right now is we didn't have a greeting method on our person. So I'm going to show you how we could do that using this syntax. This is more traditional syntax for JavaScript, but you don't necessarily need to know it. But we could get this person and get something called the prototype for it, and then add a greeting property, which is going to equal a function, which will just return. I think I'm gonna. I hope I did this right. I could be doing it wrong. There might be something wrong with the syntax. It's been a while since I've written this. Let's see here. So there we go. That's really the same type of thing. It's done very differently. And so anyone familiar with other object-oriented languages, they're going to be very uncomfortable with that. Like, what did you just do? Too much syntax so that people can feel like they know what's going on if they're familiar with other languages. And I'll talk about the differences at some point if I feel like we need to. Yes? Let is just, remember let is just the new replacement for var. That's just a variable name. Yeah, I could do whatever I want with that. Something X out of that. Any more questions on that right now? Okay, I'm gonna spin this back up and put our class back in here so we can use it. Because I want to talk more about, used an important word there when you were talking about the me or whatever, is each time you use new to create an object, it is a unique object instance being the key word here, from any other object created from that class. So it's not the same as any other one. So if I did let, all right, and then let me create another one. Let me see. Let's do lowercase. So even though both of these, like if we looked at them, they're from person objects, if we like compared the two, they're not the same thing, right? And that sort of makes sense here, right? Because if we looked at Daisy, all right, well, the name's different. So of course they're not the same thing. But just to make it clear that it has nothing to do with the properties on them, each instance is different. We could do let also me equals new person. Also me.name equals Jared. And so now if we looked at me and also me, we see it looks like the same object from outside, but it me equals also me, it's false because they're not actually the same instance. Does that make sense? Is that confusing? little bit confusing.
Okay.
So,
Yeah,
so in that case, they are not only comparing the properties, right?
they're not comparing the properties. That's correct. So let's, I'm gonna step to the whiteboard and sort of show, this is where you get into the memory pointers and stuff like that. Let's talk about what's actually happening here a little bit, because this is where it makes it important to know what's going on. As we dig deeper into this, it's going to be more important to have some sort of mental model of what's going on in memory. So we'll do that here. So if we have, here's our first section of memory. Wow, even these bad markers are dying. I'm not going to have anything next week. So I created these, right? Oops. These 3 variables, and I did it sort of bit by bit. So first I created me, and what happens here is, I talked about this a little bit before, it actually, instead of creating that here or anything else, it goes over to another section of memory and says, all right, you point over here to this bit of memory now. And this bit of memory has a name in it, which happens to be Jared, right there, and it has, you know, whatever this greeting function, or anything else that's in there. And then we created, using new, another separate object, and this one has a name in it, which is Daisy, and whatever else is in that object. And then we created yet another one over here, which we gave a name of Jared and the other properties. So when we're doing that triple equals comparison on an object like this, what it's checking is, does this arrow off of this point to the same place in memory as this arrow off of this? Right? They're not the same thing. So even though it doesn't compare the properties on them or anything else, they're 2 completely different things. Now we can change that. So I'm going to do backup equals also mean. So this is teaching you a little bit about memory here. I feel like you have to know some of this to get objects effectively. So here's what we just did there. I created another variable here. I called it backup. And what I said is, by default, what it's going to do when I assign like that is it's going to say, you point to the same place that also me points to. But it points to it separately, right? This points to it, and this points to that. So now, can anybody figure out how we could get also me to point to the same thing as me?
Also me equals me.
Yep. So now what we've done here is this pointer has changed, and now this is pointing up here to the same thing up there. So now what's going to happen when we do me equals also me? It's true, because they're pointing to the same place now.
So they're the same instance.
Yes, they're the same instance. Really the key there is they're pointing to the same place in memory. But yes, and so now if I changed like if I did also me.name equals that, then if I did like check me, we can see that I changed the name of both of them. But if I look at backup, it's still the original because it's pointing at that other location in memory, right? That makes sense? And you guys haven't really talked much about this before, right? It's sort of new. Okay, this is going to be, so building a mental model like this is another one of those really important things for picking up programming, being able to think about where stuff points, because that's the way most languages operate, most objects operate off of this sort of model. And so it takes a good while to start building up how some of this stuff works, but never feel like you shouldn't be able to just draw stuff out. Like I still today bust out, you know, a whiteboard or a little sketch pad to draw where stuff is in memory when I can't figure out what's going on sometimes. So that is a very useful way to break stuff down. All right, so let's continue to talk about classes. Let's get into them in more detail, some of the other aspects of classes. So we've had our most basic version of one so far, but the next sort of fundamental aspect of a class is the constructor method. So this will vary depending on language. In JavaScript, it's called the constructor. Some others might have an initialize method or something like that, but constructor method is a special method for creating and initializing an object created with a class. You don't call the constructor directly. Instead, it is called when creating an object using the new keyword. So in actuality, this object that we have here, where we don't have a constructor method that we defined ourselves, there's still a constructor method being called. We just didn't define it ourselves. And you can set properties of an object in the constructor using the this keyword. And again, we'll get into more detail about what this means in a little while and talk a fair bit more about that as well. But let's look at, let's take our person and let's modify it a little bit, because you were talking earlier like, oh, you set the name property on this instance, right? Well, we can do that automatically using our constructor using this syntax. So if we take this and we're going to replace what we had over here, I need to start node again so I can blow away my environment. And now we have a person object, but we have a constructor method. And it expects a name property, which it assigns to the when it gets created. Does that make sense? So if we create one, right? Let me equals new person. This is essentially, this person bit here is essentially invoking the constructor. So I need to pass into that parameters for my constructor. So that's where I'm passing my string. And now if we look at, it has a name, right? That make sense? It sort of magically gets called. It's this magic method built into your objects. For the most part, makes sense? Any questions? Yes.
Question, but we go back to like kind of way back to the slide with the notes about creating the object and also.
Oh, sure. Yeah.
Question, since it's expecting you to pass something, if you don't, are there any kind of problems or errors? Or just be blank?
That's a good question.
I would assume that.
That's a good question. What do you think is going to happen if we create a person, we don't pass a parameter into it? What? It's going to fail? All right, we've had null, we've had it's going to fail.
I actually think it's going to be fine.
You think it's going to be fine? Empty string? Any other guesses? This is good. I like this. I encourage people, I strongly encourage you, if you ever have any questions like this, run the code and try and guess and see what's going to happen, and then see what happens. Never ever, like in a modern programming language environment like any of these, you're probably never going to break something to the point where you cause a real problem. You would be doing something crazy weird to mess something up like that. So fire up Node, open up your dev tools, play around with it and test it. So let's give it a go. We've got our, I need to shut down this application that's doing that. So we've got our thing here. All right. let's see here. Superman. Well, we're gonna be using Superman. Let's do Dan, right? Equals new person, but we're not going to pass anything in. What were all our guesses again?
I think you say expecting something.
It's going to say using the name will be no. You think it'll throw an error of some kind? It's a good guess. All right. So it was fine and it's undefined. Does anybody know why that's the case?
Is taking default constructor?
What?
Is taking the default.
Nope. Yeah, in JavaScript, that's a good note. And I don't have it in my notes anywhere. In JavaScript, you're only allowed one constructor. In some other programming languages, you can have different constructors with like different numbers of parameters, which is known as like method overloading. And it will figure out which version of it to call based off the parameters. That doesn't exist in JavaScript. So you're only allowed, in fact, if you tried to declare a second constructor, that would be an error.
There's only one.
What?
There's only one creator.
There's only one, yeah. Well, we'll see in a minute that may not be exactly the case, but yes, your object or your class can only have one constructor. So anybody explain why it's undefined? Any other thoughts? What? Because we didn't define it? So let's do something.
It's like you did before a variable, which you didn't want to give a value.
Let's see what happens if I just tell this, I want to repeat my text. I'm just going to return my text. That's it, hello, I get hello back. What happens if I don't pass it anything? Yeah, so what happens is anytime you call a function in JavaScript and you didn't give a parameter, a value to one of your parameters, then its value is undefined. So that's really all there is to it. It called this constructor, but since there was no value for this parameter, its value is undefined, and that's what got assigned to name. And we didn't have any check against that, right? Now we could, if we wanted to be careful, you can write your own checks for that. So let's, this is getting into stuff that's more complicated, but let's say we do want to sort of protect that a little bit, right? I'm going to write this out myself instead of doing this. So let's create a class person, and it's going to have a constructor which expects a name. And now what we could do, and you guys haven't written stuff like this very often, but this is sort of known as like defensive programming, where you're not just assuming that stuff is correct, you're going to make sure that it is by validating it and dealing with the situation if it's not. So there's a lot of ways we could handle that. The most basic here could be something like an if-else, right? If name, and we don't have to do anything else because undefined is falsy and null is falsy and an empty string is falsy. So if name, that means that we did get some sort of value here. Then, all right, I feel pretty confident. Let's do this dot name equals name. Else this dot name equals like no name provided or something, I don't know. Right, in my constructor, I'm just gonna be lazy and not create the full one with a greeting here. We could always do let create a person. We did that. So we got the value like no name provided. But if we provided one like as a value, right? So that's some defensive programming type things, right? Where you're sort of protecting yourself against an error case. Some languages will have some of that built in where, it wouldn't let you do that. JavaScript is much looser, so you can make this sort of call. Now let's just do a quick puzzle. Can anybody think of other ways that this code that we wrote here could still go wrong from what we might expect?
Maybe we can pass more than two values.
I could pass more than one, but it's not going to hurt because it'll ignore the other ones because it's not looking at them. So that's it's a good thought. What if, well, we're sort of expecting name to be a string. What if I passed in a number or an object, right? Not really checking against that. So if in other places inside of this class on some of my methods, I assume that name's a string, but somebody passed in an object, I may have unexpected behavior later on down the line because they didn't give me what I thought they were going to give me, right? So those are other possibilities. I mean, sometimes it's worth it to code defensively and protect against that stuff, and sometimes it's not. Usually what you'll find in most places is what's known as you code defensively on the border. So where your application or your code is getting something from somewhere else that you don't control, then you'll usually do some of this defensive coding to make sure that it's not causing a problem. But when you're just calling stuff inside of your own code, then a lot of times you don't need to because, well, you hope you didn't screw it up, right? And you can fix it if you did. Pull up the earlier example of the, so here's the earlier example of the person as well, where we were just adding the property directly to it. This is sort of what I figured that it would take a little while to get through just basic objects. So let's talk more about this. Here we go. The best way I know of to think about this is like a pronoun in English. So if I am talking about myself, I'll say, I'm going to go down to the store. I bought a ridiculously large soda at the gas station on my way here. Right? That's how I can describe myself and my own actions. Whereas if I was describing actions for somebody else, I'm going to use their name to describe their actions, right? When I'm talking about it. Well, this is sort of the same thing. This is how an object can refer to itself in methods on the object. Using this, any properties or other methods on the object can be accessed within a method. So if we go back here, right, we see that here's one of our methods, constructor. So this is just, we're adding the name property right there. And here we can reference name. And you can reference more than that, right? So we could make this more complex if we wanted to, because we could reference other methods on it. So if we like class, or oops, I'm not in Node. Made this more complicated. Class person, instructor name. I'm just going to do this all inline, so it's a little easier to write out for that. Oops, I need to return this. right? So I'm going to say something when I arrive. And let's say I'm leaving, and I'm going to say something different. And then let's just say we've got a visit or something, right? And so this is like a console.log. This dot arriving. This dot leaving. Oops, hold on. I want to do that separately. This dot leaving, and that in my class. So I could say, let me pull this new person. So you can refer to anything else on your object instance that way, using this. Yes?
I know, I'm getting a little confused because I feel like that's not really weird. So at the beginning, so when you call class person, it's like, you're like calling it. That, and then down below, the let me equals new person, Jared, and then you're giving it a value there.
Right.
It's really weird.
I get that. So the key here is you're not calling anything here. What you're doing is defining. I'll use defining something that can create a person when you call it with new. So the canonical example that everyone uses to talk about what a class is it's like a blueprint for like a house or something, right? Like the blueprint isn't the house, but what it is the instructions so that when you use the blueprint, you create a house, right? That's like the canonical example used for a class. I think it can be a little hard to follow beyond just that very loose relationship because, classes define a lot of this behavior, like these functions and things. It feels like I'm creating the whole thing and not just creating a blueprint. And we could get into very deep technical details about how you are sort of creating something, which we could talk about later, but it's much easier to think of it as still that sort of blueprint. And then this new person bit here is what actually creates this object with these different properties on it at that point. Does that make sense?
It's
Yeah. Yes?
So, well, of course we can execute. Can you create class person wherein on the visit method we forget writing this? So console.log tilde $sign arriving.
Yeah, that would throw, that would be like an error because it wouldn't see. Yeah. So if you're familiar, that's a good question, again, for somebody who might be familiar with a different language. In like Java, for example, unless there's some ambiguity, unless Java can't figure it out, you don't have to tell it this dot for method calls. You could just say arriving because it can infer, oh, that's the method on me. I know that that's on me. I know how to refer to that, right? That doesn't work in JavaScript. JavaScript, you always have to tell it this. You always have to give it that context. And we will get into at some point, we'll talk about some of the dangers of this in JavaScript. I'm not going to get into it today, but unlike just about any other language, it can also sort of, I don't know how to describe this, sort of lose its context and not refer to what you think it's referring to. And there's ways to help lock that down, and we'll get into that with React, but that's a danger that can happen when you're in JavaScript, is the way that this works is more dynamic than a lot of other languages. Any other questions right now? Yes.
So on that class person constructor, that parenthesis name, right parenthesis, that constructor name, that name on the constructor.
Yeah.
So it actually refers only to the name to the right of that one, right? So,
Yeah.
So we can change the name to say another variable, but we only change the one on the right, right?
Yes. Yeah. So for example, I could let's redo this just to be clear. I can see where that could be confusing. So let's step out of here. Go into Node and let's I don't want to copy all of that. I need to create it in line, right? So I could call this like person, I'll call it first name, right? Because that's just the parameter name or whatever. And then I could assign that to name in here. There's no relationship between those two that has to exist whatsoever. What am I missing? It's still not happy with me.
Oh, because you use the class person.
Oh, because I invoked it.
Yeah, you put that class person.
I wrote it wrong. Yeah, there's no inherent relationship between these. I just used the same one, so now like on the object name, because that's what I assigned it to, whereas this parameter only exists within the scope of this constructor function, just like any other function. And it's just the name of that parameter in that scope. Good question. All right, so let's move on to the much more complex concept with objects or classes. And this is one, you guys have talked about objects before, right? Everyone's, at least at the end of the last class, you guys were working with objects a little bit, right? Whether you were creating with classes or just directly, I think you were working with them. But inheritance is sort of the new thing that you guys haven't worked with. So this is a very fundamental concept to object-oriented programming. We're probably going to just touch, that's why it says 50,000 foot view here. We're just going to touch on what this means, at least initially, because we're not going to use it as heavily as some other classes or examples use inheritance. But you guys will definitely need to have a little bit of an understanding of it, because in React, when we're creating our class components, we're inheriting from their stuff. So what does it mean? What am I talking about? So let's do an example here. I'm actually going to rewind a minute. I want to get my person back into Node so that I have it as a basis here. And then we'll move forward. So inheritance, here's an example, and then we'll get into the details here. Remember that extends keyword that I had in square braces before when I was showing you the definition of how to create a class? This is where it gets used. So in this case, we're creating a new class, and it's called superhero. But it extends a person. So I'll go ahead and just take this and drop it right in into our code over here. So now we have this superhero, which extends a person, and we defined a greeting method in it, right? But we didn't define anything around name. We didn't set name or anything like that. But if I did, oh, sorry, superhero flash. If I do flash.greeting, we get I'm Flash, the fastest man alive. So how did the name property get set on our instance of a superhero? So if we look at Flash, we'll see that he's an instance of a superhero. How did the name property get set on him? What's that? It got inherited from person. That's right. So this, what that means is it's saying it extends a person. So it sort of gets all of the behavior and characteristics of the person class as well when we create an instance of a superhero. And since in this case, we didn't define a constructor of any kind, then what it actually did was called the constructor for our person and passed in the name parameter that we sent, which set the name value. And that's how we get back the greeting that we got. And don't worry if all of that doesn't make sense. Again, we're gonna keep diving into it, but are there any questions about just that so far? No? All right, so let's, yeah, I think this probably won't get all the way through state. We may talk a little bit about it, but so the key here is the class that the new class is extending is called the superclass. So in this case, a little confusing because I used the superhero example. Maybe I shouldn't have. The superclass of superhero is person. And a constructor, we'll show this in just a second, can use the super keyword to call the constructor of the superclass. So in this case, we didn't, and since we didn't define our own constructor, it automatically called the constructor of the superclass. Because looking for construct B1, but it may end up going all the way down to the base object built into JavaScript and calling the constructor for that. But we could write it a little differently. So let's take our superhero. I need to go back to my person again because I need to start from scratch because I can't redefine I'll show you what will happen if I try that real fast. But if you defined an object using or a class using this class syntax, you can't redefine it because it'll yell at you. I got a syntax there. Identifier superhero has already been declared. So I can't change my definition of my superhero class if I've declared it that way. So I'll step out of here, start up node again. Go back and get my person. So I have my base class in my environment. And we'll step over here and create our new superhero. And then we'll come look at this in a little more detail as well. So here, we've got a superhero that extends a person, but we also have our own constructor on it. And this does some of its own work. Now, there are some special things you need to know when you're dealing with a constructor that is on a class that extends another class. And one of the first things is before you can reference this in this constructor anywhere, you have to call the super constructor. Otherwise, it won't work. So if we had tried, before we commit this call to super, if we had tried to set like this .secret identity, it would have been an error because this didn't exist at that point in time. So you have to call down to the super. Now, in this case, I'm doing something a little different. You know, the super isn't just getting everything. I called down to super and just gave it the name. And then inside of this constructor, I did some additional work, like secret identity equals secret identity. So let's go ahead and create let's do Superman, new superhero with the name of Superman and the secret identity of Clark Kent. If we looked at it, we would see, here we go. We're a superhero with these two. And because a person has a greeting, we can call greeting. And what we're calling down to is this greeting on our person. And that works just fine. But we also have our own greeting, like trusted greeting, which is different. And that references both the name and the secret identity.
What happens like if we have like same method, same name in person and super?
What happens if we have the same name, same method?
Yeah, same.
All right. It's a great question. I'm going to change my syntax a little bit here so that I don't have to redeclare or start up node again every time.
Yeah, I thought you should an example where you have greeting.
Yeah, that's what I'm going to do. So here's, don't worry too much about this slight syntax change. I'm going to be going from what's known as like a class statement to a class expression, but it won't matter that much. So we have our person. This is fine. All right, so I think this will work. Let me see if this works. I want to change some things that can let me. I don't know if it will. May error out. All right, that happens here. I gave it a name, it's still not going to work. You know, it will. Okay, cool. Okay, so that's what we have right now, right? But let's change it a little bit, as you were suggesting. So let's change our. Again, this isn't a big difference. The only difference is I'm assigning it to a variable instead of the class expression or class declaration. So that lets me modify stuff. I think this is the right syntax and should work. So if we do a constructor, we got a name and secret identity. And we call super with the name. This dot our secret identity. And then we're also going to have, you wanted to just use the same greeting, right? And I'm going to steal this so that this greeting is what will return. I hope this will work. Let me see. Superman equals new superhero. Superman Clark Kent. So because I changed the what this superhero variable refers to, this is now should work differently, I think. So what's going to happen if I call Superman.greeting? It'll use the new greeting that we created here. All right. Any other guesses? Who thinks that's what's going to happen? All right. Who has no idea? All right. So let's see what happens. All right. So what we got is the new greeting, right? So basically, what happened is we sort of overrode the old one, but not really. I'll hop on the board in a minute and sort of show how some of this works. But we could still have access to the old greeting, because. Well, let me ask you this: how did we access the constructor for the superclass? We used the super keyword, right? And we invoked it. So you can actually do the same thing. The syntax is just a little different, because you have to tell it what, like, if you call super directly, it assumes you're invoking the constructor. So, but super gives you a reference to the superclass object. So that is an object, just like anything else, and we can refer to stuff on that object. So we can take this bit of code here and let's rewrite it. So we'll make our superhero again equals class extends person. Copy this stuff. So let me now the greeting. I'm going to refer to super dot greeting, invoke it, and then but the key here is I'm only returning a value from that, right? So I'm not going to see that by default. I'm sort of cheating here. I should be, like, to actually see something, I should be doing like console log. So there's a little bit of a cheat here. So let's I'm going to do it this way. Let's take what was, or I'll just console.log right here. Super.greeting. And then, you know, I can stick with my return value that I have here. In that, uh-oh, I may have a problem. My indentation, it may not be happy with the way I copied stuff over. All right. So let me try this. Let's see if this will work instead. If I can start with this. That doesn't look good. Wait, is that copying from the wrong one? I want to copy this. No. All right, I'm gonna have to type it out to get it to work. Yeah, this is all wonky now. All right. While we're on this, submit what we were trying to do up there make sense? And if so, what do people think is going to happen when we run that code? Any guesses? No guesses? Should in the greeting, that should in that. All right. So now, if I did Superman equals new superhero, Superman, Clark Kent. What's going to happen when I call greeting here?
It's gonna show both.
Any other guesses? Yep. So it showed both. There's a little bit of difference between the two because this one's a console log, so that's what we saw here. And the other one, that the only reason we're seeing it right is because we're inside of Node, and this is in a read eval print loop, so it's just printing the returned result. That's like the little cheat I'm using with the return, is it automatically prints that. But this just calls the greeting on the super class. So let's, I'm gonna go over to whiteboard again. Let's break this down a little more to understand what's happening here, right? Let's talk about what's actually going on in code when this happens, because this is how you make sense of superclasses and inheritance and stuff like that, right? And this is still a big simplification from, you know, the core level. But so what we have is we've got our sort of person class, right? And I'm going to sort of ignore that for the time being. And then we have a superhero class. And it's a little weird. I'm going to ignore both of those because those are just ways to create objects. So what happens is when we, in our main memory, when we create our Superman object using new, essentially what happens is this says, all right, go over here and create a superhero, an object that's an instance of a superhero. And what this has on it is a secret identity. And in this case, it also has a greeting. It also has something here, which is a pointer to, if you will, the super that's sort of hidden. And what that does is it points to another object. And that other object is an instance of our person class. And that has a name and a greeting on it. So this isn't, I mean, this isn't exactly what's going on. It's pretty close to what's happening in memory. So it's actually what, that's why you can reference stuff with the super, and that's why it works a little weird, is this guy doesn't actually even have the name directly on him. It's actually part of this object, this person object that it's inheriting or extending, and it gets it off of the super. So when, like, say, for example, we call the greeting inside of our superhero, where it has a reference to both the this.name and this.secret identity, what actually happens there is it says, oh, I'm calling greeting off of this, and this is connecting to Superman is what this points to or whatever. So it says, oh, I'm calling greeting off of this. All right, greeting looks for name. Oh, I don't see a name on this at all. Okay, then does my superclass or my prototype or whatever, if you will, in actual underlying JavaScript stuff, does that have a name property? Does the object that I inherit from have a name? Oh, it does? Okay, that's the value of name. And then it says, oh, no, I need this.secret identity. Let's look for it. Oh, yeah, I have a secret identity. So we're good to go. You know, I've got everything I need. And then for the greeting, when we called greeting, it called to this. And then we use this super reference to access the greeting in our superclass. Does that make sense? There's a lot of complexity to this. There's a lot of stuff going on. It takes a good while to get completely comfortable with what's going on in this sort of object-oriented paradigm. But that's generally what's happening. Again, you won't probably, for what we do in this class, need to know too much about it. But it's important to have a basis of it for any modern programming, because every language uses objects in some way, shape, or form for the most part, and a lot of them are much more closely tied to classes and this inheritance model and stuff like that. Making sense right now? Any other questions on that so far? Oh, I ran out of slides as far as I got. So that's sort of the basis of building out objects and inheritance, right? This inheritance stuff can go down more than one level. So there could be, this chain can keep going. So if we were to, I'm gonna again start from scratch here. Let's X out of this, startup node. We could create multiple levels of this. So we could say class animal, and create an animal class. And this is a very common example. So I'm falling back on like traditional object-oriented teaching stuff here. And let's say it has a speak method. You know, so this might be like console.log. I don't know what just any random animal would say. Right? And then we could have like a class person extends animal. And maybe this one has a constructor which expects a name. And this dot name equals name, like we just had. And this one also can speak. Sassy, I don't know. What? Your, yeah, sorry. Cranky, it's a cranky person.
Although they just did screw up the name.
Yeah, I know, that's the funny part. Right, and we could, we can keep going, right? We can have a class like light person. And they speak, and they're going to say, oh, they do, yeah, thank you. Which I think it's too late for me to get back up there, so I'm gonna have to step out of this. We'll see if this is broken now. Sends a person. Right. They have a speak.
They can use name.
They can use name because they didn't define their own constructor. So when we create a polite person, it's going to walk the chain of classes, the superclasses, looking for a constructor and call the first one that it finds.
Oh, right. I was thinking, for some reason, I thought the top one was person and the next one was.
Yeah, so if we created just an animal, right, like a basic animal, and we could have it speak, because you can create that, right? We can create a person. It's a new person, and they're gonna have a name. I did something wrong. Oh, yeah, see, here's the deal. You notice what I said earlier? See, now I can't go fix my person now, so now my whole thing's broken. It's a shame. I said you can't access this in the constructor until you call the super constructor if you extend another class. And since this was extending an animal, I didn't call super for my animal, so I couldn't access this. That's the error that you get as a result of just that, right? Reference error. Must call super constructor and derived class before accessing this. So whenever you're extending, you always have to remember, if you're writing your constructor, you have to call the super class constructor before you do anything else in your constructor, or reference this. I mean, you can do other stuff outside of referencing this, but you always have to call the super one if you have your own constructor.
That would be like separate name.
That would be in the constructor. It'd be like right here. And yeah, you would do like super, and you wouldn't necessarily have to pass it the name, because in this case, we have knowledge of what our super class is and we know it doesn't care about that name. But you know, you might. Make sense? Yeah.
So how do we call the super? Just enter super.
Super with the parentheses, yeah. Yeah. That's how you call it. So I could redo all this, but I don't know if we want to spend the time typing that out right now to get it correct. Only if it needs the parameters. And there's actually a little more to it than that. It's a little, there's some weird magic stuff that you know, we don't need to go into too much, but basically only if the super actually needs parameters. Like if the constructor for the superclass needs them, then you need to put something in there. Otherwise you don't. You can just invoke it. But yeah, you'll find tons and tons of examples of object-oriented programming doing all sorts of stuff. You know, usually like people, rectangles and squares, like, you know, objects. These are the ones that you'll see a lot of examples of doing this extends. So this is where I now step aside and give you the counter warning, right? We talked about you can inherit from other objects, you can extend. In general, you don't do that very often in programming. It's very common when we teach programming, for whatever reason, we teach something, and then after you get out of school, everyone's like, try not to extend your objects. And you're like, great, you just taught me that that's the way to code for forever. But in general, you don't extend a lot. There's a term known as prefer composition over inheritance. So prefer to compose an object out of other objects as opposed to inheriting from objects. And there's a lot of reasons for that. They get deep into, like, make a lot more sense after you've worked with it a lot. But inheriting is the strongest binding you can have, the strongest relationship you can have between two objects. It's this very tight relationship. And usually objects aren't perfectly relatable in that way. And so some stuff doesn't make perfect sense when you do inheritance. And so it can lead to a lot of weird having to override things in ways like, we can go to even one of the most basic classic examples that is used in tutorials, even has a little bit of oddity to it. So let's do a rectangle, right? Let's create a rectangle class, and it has a constructor. And what are the two properties we should pass into a rectangle to make it? What? Length and width. All right, sounds good. So this dot length equals length. This dot width equals width, right? Sounds good. And let's do like, I don't know, yeah, get area method on it. And this will just return this dot length times this dot width, right? Very, very simple rectangle. And we can create instances of it, right? Like very basic rectangle equals new rectangle, like 3, 4 rectangle, right? Rec dot get area. Oops. Oh, it's all messed up because of the earlier line. There we go. It's pretty simple. And one of the most common examples that you'll see when you're learning object-oriented programming is like class square extends rectangle, right? Except there's some differences between a square and a rectangle. What's the fundamental difference? The sides are the same, right? Okay, so now we say, well, what makes sense? Well, we need to create a new constructor because we only need to pass in one value, right? But what do we want to do here? Like, this is one of the most common examples. How do we reuse bits of the rectangle with our square, which only has one value, right? What do we do to try and reuse something? Like we don't want to have to rewrite get area maybe.
Could class square call the creation of a rectangle that make both of the sides the same?
We can, yeah. That's the typical way this is done, right? Where we're going to call the super for the rectangle, and we're just going to pass in the length for both of the parameters. So that becomes the length and the width, right? And that's all we need for our square because we get to use the get area from our rectangle, right? So we can make a square like and we can compute the area and stuff. But even then, you can begin to see how like it doesn't really fit perfectly. The square isn't just changing some minor behavior of a rectangle. It really has sort of a fundamentally different behavior. You can't have different lengths of sides on it. So if we started adding in other properties of rectangles to our rectangle class, we'd begin to see like, oh man, the square doesn't fit here. We have to special case and do something different over here and do something different over here. And so even in these very common canonical examples, binding that you didn't intend, or you have to override behavior because you're really changing it. So that's why a lot of times it's said, prefer composition over inheritance. All that means when they say composition is create instances of other objects and set those as properties on your object. So that's we could always get into more on that. That's getting into software design principles and how to build stuff out. But there are use cases for inheritance when you really want to get some existing behavior and you're relying on that. And that is sort of the basis for React like class components, is using some of this inheritance stuff. So we'll take a quick, we're definitely getting near the end here. I'll probably do some assignments. I don't think I'll get them out before Thursday. Obviously, there's such a short gap there, but I'll try and get you some assignments this weekend where you're taking some objects or something simple and making them classes and trying to just get some practice typing classes in so that you do that a fair bit. But let's take a real quick glance at the concept of class components in React. So let me see here. I think they show it. I think this is the first time you see it. So we've seen something like this before, this welcome component, right? This is our functional type component. We're just saying, printing out an H1 or giving back an H1 element with a props.name. Well, you can write the exact same thing as a class component too. And we'll get into much more detail about how this works next time. But the key here is you're extending React.component, which is a existing class that React provides, which gives a lot of component behavior. And one of the things that React.component has is a render method. So you need to provide a render method. So what you'll see here is it's a pretty direct mapping with a couple of minor differences. You take what was the body of this functional component, and you put it into this render method. And the only other difference between the two, someone else spot the other difference between the two there for the most part? Use of this. So on a functional component, you don't have this to refer to yourself. So you just name your property whatever you want to call it, typically props. On a class-based component, React defines what the properties are that you pass in and what they're on, and that's this dot prop. So this is just referring to your instance of your object, and props is the name of your properties or any attributes that you passed in, right? So these are what get mapped to your props, is anything that's these sort of attributes on your element. But that's the most like, we'll also, after the next class, when we go over this a lot more, I'll have, one of the things we'll be doing is more hands-on next time and taking a lot of the stuff that we've already done for components and just converting them to class components, just to get practice doing that, even though they won't have state at first. And then we'll add in the state as well. It's getting toasty in here. But yeah, I don't want to start piling on all the state stuff on top of what we already talked about today, because learning classes in JavaScript is, you know, masterclass itself. If you really want to dive into it, MDN, which is a great, they do the Firefox browser. They've got great documentation. But let me see here. I think they have a better one than this. Even. Is that at the bottom of this? Uh-oh. So they've got a lot of great documentation, but here's even one of them, like great blog post and other stuff on writing into JavaScript. And they go into a lot of stuff that we haven't talked about, very in-depth. But some of it shouldn't be too different. Like this example right here, that looks like something that we would have written just now in class or anything similar. But you can, if you really want to dive into it, double check stuff, you can read up on some of this stuff and learn a lot more about how that works. They have classes in their introduction. I don't know if they do. No, I don't think they do. All right. Any questions on classes, objects, anything along those lines? Yeah. Nice. Okay, then, quick question. Who spent time trying to, I know you did for sure, we can take a look at that. Who spent time trying to break down the couple other sites that we sent out into components? Yeah? How did that go? Were there any difficulties or real challenges?
So I felt like the geo practice was
The geo practice?
that website.
Mm-hmm. You felt like, ooh, this is pretty good. Look at that. Yeah, so you were saying, all right, let me go up here to where we have them. Wait, where did we send them out? Here we go. Oh, we also talked about Y Combinator as well. So for anyone who did break it down, what did you end up breaking it down as in terms of components? Let's go to this one. You said you felt like this one was easier, right? So what did you have as components like for Hacker News?
Lists, coding, uploaded. That's one. And like choose the new comments like up top.
Right.
And then at the bottom there's a search bar.
Nice. I like it. Did anybody else break this one down? So this is, again, like, wasn't asking you to necessarily code it up, which I think is amazing. But just thinking about how you break stuff down, right? So that we can start building that mindset. So if I'm breaking this down, I don't know, I'm doing this on the fly. I've got like I'm calling it like my app or something, maybe. And then at the top, I've got like probably my header. And that's going to have things inside of it these different pieces, like, like you said, the new, the threads, the comments. These are all probably some version of like a link or something to go to another page. So I'm probably thinking like I've got a generic link component to use here. And then, yeah, I'll have like a list or like I don't know what I would call these articles, article lists, something like that. And then each one of these would be like an article with its own. Then you could break it down into all sorts of levels, right? You could leave it at that, or you could break it down even more, where it's like, okay, then you have your voting portion of your article. Like your article might be composed of a voting section and a title section and details or something. What? Right. So I mean, there's a lot to, like, you could break it down at just about any level, but there's a lot to break down and to turn into these reusable bits, because you're looking at it like this is definitely a reusable piece. It gets repeated over and over, and that same pattern is there over and over. So thinking of that as a component that gets reused is really nice and useful in terms of being able to construct your UI. So let's take a look at what we had over here for this one. Look at that, it's even responsive. I'm gonna hide this stuff and just focus on the JavaScript. I really like laying out the thought process, right? This gets to that concept of abstraction or other stuff that I was talking about. Is I strongly encourage, whenever you're working on stuff, to don't try and solve all the problems you're dealing with at once. Assume that they're solved. That's a weird statement, but assume it's solved. Like, so that's why I've talked about just learning how to break it out into components, because if you say like, oh, we have a GeoPractice or practice thing, and then we have a main menu component, and then there's a game component, and then there's a footer component. Now this is broken down a little weird because this like main menu isn't self-closing, probably because the home links and menu buttons are inside of it. But that's just sort of at some point assume that that's how stuff works, and you can assume this exists. And then, okay, well now I have these other things inside of it. And finally, when you get to the bottom, you can start building it out and construct it back up. But if you assume that stuff works, that's a great way to code too, is assume a function exists that does something magic for you. Call it, do the work around that, and then go down and implement that function that does whatever that magic thing is. Because that's how you build on that idea of abstraction. That function is your abstraction. These components are the abstraction here. So then we can look at what's actually going on here too, which I haven't really looked at that much, but it's pretty well put together, I would say. Got a lot going on, and then we'll definitely be able to add in actions and stuff and states after the next class if we want, and build on this even more. All right, well, let's get out of here. It's like scalding in here. You animal. This is not, like, what's the question? I don't understand what I'm supposed to do here. I'm lost. There's too much information.
To answer it?
Like, unlike most other animals, in this animal family.
Very worded, very weird.
Yes. I don't know, because we don't have any interaction. We can't find an answer yet.
Find it in the in the JSON.
No, okay. Go cheat.
Yeah.
What are deer? Oh man. All right. What are deer? All right. Get out of here. Oh, I need to shut off my